All right, so let's suppose that your neighbor comes up to you and says, I want you to shovel snow for this winter, the entire winter, every time it snows, and I'll let you decide how you get paid. I'll give you two options. So the first one, you're going to get $5 the first time, and then $5 more each time you come to shovel snow. 1 penny is your second option, just for agreeing to help. So I will hand you a penny just because you came in and said, yeah, next time it snows, I'll come shovel your snow. And then double that amount every time you shovel snow. So, with that being said, I want you to pause the video, give that some thought, and then decide which option you think you would pick. So, again, pause the video and make a good guess at which one you think you're going to make the most money. Okay, so at this point, probably what I would do with eighth grade and the math skills we have so far is I would make two tables. So, our first option, when we don't go at all, we are going to get no money, right? So, it is zero. So, our starting amount is zero for our first option. But the first time I shovel snow, I'm going to get $5. Then I'm going to get five more, then five more, then five more, five more, plus five, plus five. Keep going. It's adding up pretty fast, looking pretty good. Not a shabby option if you chose to get $5 every single time you went to go shovel snow. Especially if you had a winter where you had 15 chances to go shovel snow, you made $75 that winter. That's amazing. Excellent. And all we did was add five all the way down, like every single time we added five. And hopefully you notice this and recognize this as a linear function, which we should have already learned. And you should have been introduced in eighth grade math, but we've definitely been doing it in our class as well. So that means that every time we shovel snow, we're going to get $5. So that's y equals 5x. There's no number after the 5x because if we don't shovel snow, we're not going to get paid at all, right? All right, so our number two option. So when we don't shovel snow at all, we still got 1 penny. So we still received a cent for just saying we would do it in the event it should snow. Then our second time, we would end up with 2 cents. Then we would end up with 4. And then we would end up with 8. Double that, 16, because he said he's going to double the amount every time. So then we end up with 32 cents the next time total, 64 the next, $1.28. Now we're getting into some real dollars. 256, 512, 10, 24, 20, 48. All right, we're starting to make some money now. 40, 96. That's looking good. 81.92. All right, now we're breaking above our initial plan, our first option. 163.84, and then double that, we get $327.68. So ultimately, I don't know which one you chose, but in the event you should be living somewhere where you get 15 snows during the winter, you are going to make way more money with our function over here as it doubles all the way down. So versus that plus 5 all the way down, we went times 2, times 2, times 2. So it is still a constant rate of change, but it is a multiplication versus just your addition. So linear is addition and subtraction. It either grows as an increase with plus or it decreases with a minus. Our new functions that we are starting to work with today are going to be exponential functions. And that means it is going to grow at an exponential rate, like it's going to double or triple or quadruple or by a percentage change, not just a flat plus 5 plus 2, minus 3, anything of that nature. And the way you can check all tables is go down your sides, just as I just showed you, and see that it's multiplication versus addition. So I don't know which one you chose, but again, if you're living in a big snowy place where you think you could probably get 15 snows, or actually I guess even 13 snows is when you start winning on our second option, then I would definitely choose your second option. But if you're living in North Carolina, obviously your linear choice is probably a lot better because we haven't gotten that many snows and you're making $30 with 6. Okay, so to compare linear functions versus exponential functions, just in the way they look. So linear function, we know that b is our starting value. In our exponential function, a is our starting value. So a is going to be our starting amount. Initial amount is another really great word they use. Initial amount, as far as using different websites, different teachers' tests, initial amount and starting amount or starting value are the exact same thing. So for a linear, m is our rate of change or the slope. So at which the rate that it grows, right? So then for a exponential function, that is going to be your b value. So if it's going to double, that would be a 2 there. If it's going to triple, it's going to be a 3 there. So b is our growth rate. And when b is greater than 1, that means it's getting bigger. So 1.5, 2, 2.75, 3, 4, 8, 12. If it's bigger than 1, then that is a growth. If it is smaller than 1, that means they're dying off, and that is decay. So if b is smaller than 1, so the number with the exponent attached to it is smaller than 1, it is a decay function.